Hey everyone, welcome back. In this lesson, we're going to continue with the word problems that we started working on last time out. These word problems aren't necessarily more difficult than the ones we were talking about last time. In fact, these ones are probably easier than that last one we did because we don't need any special formulas for this one. All the information that we need is going to come directly from the question itself. So, just like last time, I'll start off with the title and we'll write out the first problem, and then I will get rid of the problem to make room to actually solve it. So this one, this video will also be 3 word problems, but we're going to go a smidge faster than yesterday, I think, just because well, we've seen this topic once already with word problems, and that's 3 examples more of working with this single variable algebra. So hopefully we can handle going a little bit faster. The first 2 questions have a really similar setup, and then again, just like yesterday, the third one's a little bit different, but it's not that difficult. So we'll start with the first word problem, and this one is as follows. So the sum of 2 numbers is 22. Right, the larger number is 2 greater than 3 times the smaller number. Find the numbers. Alright, so that's the question that we have in this one. So we've got, I'll just read out the whole thing before we start writing anything down. So we've got the sum of 2 numbers is 22. That's important. Alright, so the key words here are the sum and 22, and perhaps 2 numbers as well, right? So the sum of 2 numbers is 22. The larger number is 2 greater than 3 times the smaller number. I know I just underlined a lot right there, but basically the larger number, so it's going to be 3 times the smaller number plus 2. It's 2 greater than, so it'll be 2, well, we could say it's 2 greater than something, so it'll be something plus 2. What's that something? 3 times the smaller number. So if, let's say, we'll write a let statement and all in a sec, but if the smaller number was x, then it would be 3 times x, so that's 3 times the smaller number, and then it's 2 bigger than that, so it's 2 greater than 3 times the smaller number. I'm going to leave that there just for now, but you don't have to write that just yet, because we're going to rewrite it when we put our let statement together. Alright, so this is what we have so far. So we've got the sum of 2 numbers is 22, the larger number is 2 greater than 3 times the smaller number. Find the 2 numbers. Alright, so I'm going to get rid of our title here, and if you haven't written down the question in full yet, you can pause the video just for a sec so you can finish doing that. But we're going to start putting together our let statement. Now the way I tend to do this, and the way I was, I guess, taught to do these problems, is generally speaking, well, sometimes it'll vary depending on the setup of the problem, but for this one, the way I sort of set it up was I let x be the smaller number. And the reason for that is because we describe the bigger number in terms of the smaller number. So here's the first part of our let statement. I'm going to get rid of the question in just a sec. But for now, I'm just going to get rid of the first sentence. We know the sum of the 2 numbers is 22. Now, if you look here, the larger number is 2 greater than 3 times the smaller number. So that whole description, it's describing what the larger number is. And in order to describe what the larger number is, it's using the smaller number to give you that description. So that's telling you that the larger number sort of the way it's written, the larger number depends on the smaller number. If the smaller number is a certain value, the larger number is going to be 2 larger than 3 times that smaller number, 2 greater than 3 times the smaller number. So the larger number, its actual value, depends on what the smaller number is. So I'm letting x be the smaller number because that's sort of the key. That's what we need to find. And then we can figure out the larger number based on that. So that's where this thing that we have down here comes in handy, because we can put a statement right below that, which is, so if x is the smaller number, then the larger number is, and that's this thing that we have down here. It's 2, so we have the 2 here, that's this 2 right there, greater than, so it's bigger than something, so it's going to be something plus 2. So that's where we have this plus sign and this 2 coming into play. So it's 2 greater than something, and what is that something? That's this right here. It's 3 times the smaller number. So this whole thing in here, this 3 times the smaller number, is this 3x over here, right? So it's 2 greater than 3 times the smaller number. Now if the smaller number is x, then 3x is going to be 3 times the smaller number, and then it's 2 units bigger than that. It's 2 numbers higher, right? So then we can say that the larger number is 3x plus 2. Okay, so now I'm going to get rid of this question, and we want to figure out what the 2 numbers are. Now the one piece of information that I erased without actually writing anything about it is the sum of the 2 numbers. We know the sum of the numbers is 22, and remember, sum means addition, so it'll be the smaller number, smaller number plus the larger number equals 22. That's what we know, right? Now the smaller number is x, so I can sub in x right there. The larger number is this thing right here, 3x plus 2. Right, so here's our smaller number, this x. Here's our larger number, 3x plus 2, and that whole thing equals 22. Now since the smaller number is x, we do want to make sure that we're actually solving for x. So let's go ahead and solve for x, and that'll give us the smaller number, and then we can go and figure out the larger number based on that. So if I group these together, I'm going to get 4x plus 2 equals 22, right? Now I could also actually just get rid of that 2 right now. I could take this 2, basically we're subtracting 2 from both sides, so I'm taking this 2, chucking it over there, and what we're going to end up with, I'm going to have to erase this part up at the top, what we're going to end up with, I'll just erase the let and the then statements, hopefully you guys have got those down. X is the smaller number, and 3x plus 2 is the larger number. That's all that we had up there. So then I've got 4x on the left side, and then on the right side it's going to be 22, and then when I take this positive 2 over there, it's going to become negative 2. We're going to subtract it. 22 minus 2 is 20. But I don't want x times 4, I want just x. So I'm going to divide both sides by 4, and then that means on the left side those 4's are going to disappear, so I'm going to be left with just an x. I'm going to have to get rid of this so it's just so you can see where we are. I'm going to have just an x on the left side, and then on the right side we've got 20 divided by 4, which is 5. Alright, so now we've found the smaller number has to be 5. Alright, now based on that we can figure out what the larger number is. So there are 2 ways to do that. One is to plug it into the thing we got for the larger number, this 3x plus 2, which is the way I'm going to do it, just so that you guys get some practice with that. The other way is, we know the sum of the 2 numbers, that is, if you add the 2 numbers together, you'll get 22. And you know the smaller number is 5. You don't even care that it's a smaller number. One of the numbers is 5, and you know that 5 plus something equals 22. So you could just do 22 minus 5, and you should get your answer. But we're going to do it the other way. So that's one way to do it. 22 minus 5 should give you the right answer, which, if you have gone ahead and done that subtraction, should give you 17. But we know the larger number, so you could even say but the larger number, or you could say and perhaps, which might be more appropriate in this case, and the larger number is 3x plus 2. And we know 3x plus 2, well, we know what x is, so it's going to be 3 times 5, because we know that that's x is equal to 5. So we've got 3 times 5 plus 2 is the larger number. 3 times 5 is 15, plus 2 is indeed 17. And you can check then that the final answer is indeed 22. If you add together this smaller number and this larger number, you should get 22. And so then you can put a final statement at the bottom. You could put your therefore statement. Therefore, I'm just out of laziness, I'm leaving out the word the. Therefore, the smaller number is 5 and larger number is 17. Alright, hopefully you can read that down there. That's therefore the smaller number is 5 and the larger number is 17. I just left out a couple of smaller words because I'm a little lazy right now. Yeah, so that's the first problem. That's all there is to it. I know we went a little bit faster than we were going yesterday, but hopefully this is all making sense. We're going to move right along into problem number 2, which is a very similar problem. It's a little bit less obscure in terms of like what the word problem is actually asking, because I said when we were working on the word problems there'll be some sort of real life application to it, and we haven't really seen that in this first one. I've written out the problem in words, but we've still just been talking about numbers. We've just been talking about, oh, some two random numbers, those numbers don't have any meaning. The 5 doesn't represent anything. It's not $5 or 5 chickens or 5 oranges, it's just 5. And that's not what I sort of said we would see in the word problem. So here's a second one. It's a very, very similar setup, but it has the numbers actually mean something this time. So let's jump right into that problem. It's going to be problem number 2. So, problem number 2. Alrighty, here we go. So problem number 2. My dad is 4 years younger than 3 times my age. Alright, my dad is 4 years younger than 3 times my age. Our ages add up to 76. So if you add his age and my age together, you'll get 76 years. Find my age. Just mine. Alright, so that's the question that we have here. So my dad is 4 years younger than 3 times my age. Our ages add up to 76. Find my age. Now, if we were looking at the last problem, we had to find both numbers. This is another case of basically there's a smaller number and a bigger number. The smaller number is my age, the bigger number is my dad's age, and we know what they add up to. So it's exactly the same as that last problem. This one I made it slightly easier because in the last problem you had to find both numbers. In this one, we just care about my age. I'm not asking you to find both. You could find both. There's enough information here for you to find his, but I'm only asking you to find mine. So we'll put our let statement down here because we've got room for it. So we'll say let x represent my age. Let x represent my age. Alright, and we'll actually squeeze our then statement down here as well. So we've got let x represent my age, then my dad's age is, and this we got to figure out what exactly it is. Alright, so we know my dad is going to be 4 years younger than something, so it's going to be something minus 4. right? It'll be something minus 4 years. So we know, if I just sort of write it in this open space for now, we know it's going to be something minus 4, right? He's 4 years younger than something. And the something that we're talking about is this, 3 times my age. Well, if my age is x, then it's going to be 3 times my age would be 3x. Agreed? So my age would be 3x, and he's 4 years younger than that, so it should be 3x minus 4. Make sure you're not doing 4 minus 3x. That could be a common mistake, and that's a mistake that I've seen reasonably frequently. Not so much from you guys, but it's a mistake that has come up before. So just be watchful of that, make sure you're writing it as 3x minus 4 and not the other way around, because otherwise you'll be dealing with some negative ages, which doesn't work out so well. So then we can write that down here. So we've got 3x minus 4. So then my dad's age is 3x minus 4. So we've made a then statement for my dad's age. We don't necessarily need to make use of that equation later to actually figure out his age, but it's useful in the next step when we're trying to actually build an equation. We need to have a way to write his age mathematically so that we can stick, my age plus his age equals 76. So if we go ahead and do that, let me get rid of this question right here, and we'll use the open space to write that out. So we know the sum of our ages is 76. Our ages add up to 76. So my age plus my dad's age is equal to 76. Alright, now we know my age is just x. So we'll put in an x plus, and then we know my dad's age is 3x minus 4. 3x minus 4 is equal to 76. So now we can go ahead and solve. We've taken information out of the question and built this equation. 2 videos ago, this is where the problem started. I would give you this and we would solve for x. Now we've taken the word problem, built this equation out of it, and now we're going to go ahead and solve. So if I combine these terms with x's together, I'm going to get x plus 3x, that's 4x on the left side. I'm going to take this negative 4, I'm going to throw it over there, and it's going to become a positive 4. Or the other way you can think about it is I'm adding 4 to both sides. Right, so if I add 4 to the left side, this minus 4 will cancel out with that plus 4, and then on the other side we'll be left with 76 plus 4, which is of course going to be 80. So let me erase the let and then statements down here. So then we've got 4x is equal to 80. But we don't want 4 times my age. We just want my age, which is x. So we'll divide by 4, divide by 4. Oops, that's a terrible 4. Divide by 4 on both sides. This 4 and this 4 disappear, so we're left with just an x on the left side. And we're left with 80 divided by 4, which is equal to 20 on the right side. So, there you go, there you have it. There's the final answer. We've figured out what x is, and we said in our let statement that x is my age, and that is what the question is looking for. So, so then that would be the end of the problem. You could, if you wanted to, go ahead from here, figure out my dad's age, and then add the two together and see if it spits out 76. But in this particular question, and this only works this time, don't try it on the test, is you can ask me if that's the right answer. And for the next couple of weeks, that is still the right answer. I am indeed 20 years old. So then you could put your therefore statement. I'll put a therefore statement from my own perspective, which is therefore I am 20 years old. There you go, just sort of sneak it in on the side for this one, just so that we don't have to erase everything just for the therefore statement. But yeah, once you've got this age down here, you can just throw in your therefore statement at the end of that, and that would be the end of the problem, because in this one, the question hasn't asked you to find my dad's age. If you want, that's an exercise for you guys. You can go ahead and calculate that. Alright, hopefully that's making sense. Again, going a smidge faster than before, but now you've seen maybe not like a practical application in the sense of like like in a job in the workforce kind of a question, but at least there's some context to the numbers. The numbers actually mean something. In this question, the numbers meant ages of people, right? So that's it for that one. This last one, it's not hard. It's just a slightly different setup, and let's just jump right into it. We've last year I was making some math videos and some science videos. This term we've been lacking with the science stuff because you guys have got your science classes sorted out. So I figured let's throw some science into our math class and just make an astronomy flavored question. So, question 3. Jupiter is about 10 Earths across. Jupiter is about 10 Earths across, and the Sun is about 10 Jupiters across. If the Sun has a radius of 700,000 kilometers, I'm going to have to put the kilometers down here, find the radius of Earth. Alright, so that's the problem for this one. So Jupiter is about 10 Earths across. We're going to ignore this about when we're actually solving the problem, and we're going to ignore this about over there as well. So Jupiter is 10 Earths across, and the Sun is 10 Jupiters across. I had to put the abouts in there because it's not exactly 10 Earths across, and it's not exactly 10 Jupiters across. That's just the astronomy student in me. But yeah, for this problem, Jupiter is 10 Earths across exactly, and the Sun is 10 Jupiters across exactly. If the Sun has a radius of 700,000 kilometers, which it almost does, just again the astronomy student in me, it's 695,700 kilometers. We'll just call that 700,000 for the simplicity of this problem. So assuming the Sun has a radius of exactly 700,000 kilometers, Jupiter is exactly 10 Earths across, and the Sun is 10 Jupiters across, figure out the radius of the Earth. So actually, well, it's not the Sun. The Sun's not 700,000 kilometers across, just a radius, right? So that means that if you had a circle, then the Sun's radius would be from the center out to this edge. So that space in there, that line in that circle right there, is our 700,000. And so we want to figure out how big is that line over here for the Earth. So just from the center out to the edge. Alright, that's what we want to figure out, how big that is in kilometers. So, I'm going to get rid of the question because we've basically run out of room already. And we'll start writing some things down. So, our let statement. Let's say, let x represent the radius of the Earth, because that's what we want to solve for, right? Let x represent Earth's radius. Okay? Now, if x is the Earth's radius, then Jupiter, well, we know Jupiter is 10 times bigger than the Earth, so that means then Jupiter's radius is going to be 10 times bigger than Earth's. So Jupiter's radius is 10 times bigger than Earth's radius, or 10x, if x is the radius of the Earth. And similarly, we know the Sun is 10 times bigger than Jupiter, really just going across. So the Sun's radius is going to be 10 times bigger than Jupiter's. So that's going to be 10 times 10x, right? The 10x there is Jupiter's radius, and the Sun is 10 times bigger than that. So that's going to be 100x, right? That's just 10 times 10 times x. 10 times 10 is 100. 100 times x, we don't need to put the multiplication sign, and we get that. So we've got that x is the Earth's radius, Jupiter's radius is 10x, and the Sun's radius is 100x. Now we know the Sun's radius, so we know the Sun's radius is 100x, and we were told in the question that the Sun's radius is 700 7,000 kilometers, right? So it's actually quite simple here to solve for x. Like I said, it's not a hard problem the way yesterday's one was with an extra formula and all of that. We just need to solve for x. We don't even need to write the kilometers in there right now. But again, what we should have done up here in our let statement is we should have said let x represent the Earth's radius in kilometers, right? That would have been more useful for when we get our final answer. So now we know 100x, that's 100 times the Earth's radius in kilometers, is equal to 700,000 kilometers. But we don't want 100 times Earth's radius, or we don't want 100 times x, we want just x. So I'll just divide both sides by 100. So on the left side, these hundreds will disappear, and I'll be left with just x. And on the right side, we've got 700,000 divided by 100, cancel 2 zeros there, cancel 2 zeros there, and we're left with 7,000. Alright, so now that's it. We've actually already just solved for x right there. No extra work is necessary. And so you could, once again, you could squeeze in, this time I'll erase it and we'll rewrite it. You can write in a therefore statement at the end of that, because Earth's radius is what we wanted to solve for, and we said in our let statement that x is going to be the radius of the Earth. So then we get that therefore the radius of Earth is about 7,000 kilometers. I've thrown the about in there again just because it's slightly inaccurate. We simplified the numbers for the sake of this question, but that is reasonably close to the right answer. I think the accepted value for the radius of the Earth is 6,371 kilometers, so 7,000 isn't that far off if you're doing it as a simple single variable algebra problem with some rounded numbers. So we were just dealing with a bunch of tens and 700,000, and we got an answer that's reasonably close to the actual radius of the Earth. And so that's about it. That's 3 more examples here of word problems that involve the use of a single variable. And basically in each problem, you're just trying to solve for, you just choose your variable so that it's the thing that answers the question is just whatever the number the variable has to be. And sometimes you have to solve 2 things, so you have to find what x is equal to, and then you have to find what something else is equal to, and that second thing depends on x. So sometimes you have to find 2 things and it's a little bit of an extra step at the end. Sometimes you only have to find 1 thing, like in this question. I could have also said find Earth's radius and find Jupiter's radius, or I could have said find Earth's diameter, where we would have to take our answer, or really our answer down here, and multiply it by 2 to get Earth's diameter. So sometimes you'll see little extra questions like that, little extra pieces at the end of the question. Yeah, hopefully nothing overly complicated in these examples. My apologies if I was rushing. I have a couple of other things that I need to do tonight, and it's already 9:30. But I hope these questions all made sense. I'm not sure if, I believe the next video is going to be involving 2 variables. So instead of working with just x and x squared and whatever, we'll be working with x and y, or x squared and y squared, or things like that. And that sort of opens the doors to basically the rest of the units that we'll be doing throughout the term. So we won't do any crazy complicated stuff with 2 variables yet, but that stuff is going to lead right into our next unit, which is on linear functions, which you guys might remember from last year, and then after that we'll be doing quadratics, so there's going to be lots of x's and y's in both of those. I could be wrong though, I don't think I'm wrong, but I believe the next video is going to be the start of that. But before we get to that video, I am going to be making you guys' assignment. So your first assignment for this unit, possibly your only assignment for this unit, is going to be just working with a single variable, and then I'll see, I think I'd originally planned this unit to straddle the winter break, so some of the videos before, some of the videos after, so I'll need to double check my schedule about what topics are coming up, but I know we're going to be working with 2 variables in the very near future. There might be an assignment on that as well, but yeah, that's probably not a big issue right now. we'll have it sorted out by the time you guys get to this video. But yeah, if you guys have any questions, get in touch with me. I'm always checking my email in case anyone sent me a message. But yeah, if you have any questions, get in touch with me. Otherwise, I will see you guys in the next video. Have a good one.